So we want to state all the integer values of x only in this interval that satisfy this inequality. So whenever this kind of question has been given that we have to find out values of this, let's concentrate on first how can we find out values. That means solving this particular inequality first. So we will use the previous methods of solving the inequality. Okay, so what is the way we used to solve this? What is the first thing we'll be doing?
The first thing we'll be doing, wait, can you repeat that?
Yeah. So we want to solve this inequality first. So what is the first thing we will apply over here? What is the step we'll do?
There's no distribution, so
Hmm.
we're on the top question or bottom question?
Oh, top we will see later. First, we want to solve this only. And we can solve this by using our previous methods only. For example, there is
Okay.
a negative 9. What is going to be the opposite of a negative 9?
+9.
So we are doing the plus 9 in both sides. And what do we get?
We will get 4x is
Yeah,
less than or equals to -9.
perfect. And we want to now isolate x. What do we do?
We can do 4x divided by itself.
Okay, so we have to divide with 4x.
Oh no, just 4.
We'll have to divide with just 4. Okay, so if we are dividing with only 4, what are we left with?
We're left with 4. Wait, x is less than or equals to 9 divided by 4. 1.75. I mean,
You said 1, right?
no, it's 2. My bad.
Okay.
2.25.
2 gives us 8. Then we can take as many zeros. Get a 0. 2.25 as you said. Okay, 2 is correct. And then we got a 2 and we can take down this 0
Oh,
over.
2.5. But it's a negative, right?
Yes, it's a negative 2.25. Now, when we have solved this, now let's look at what are they saying over here in the question. They are saying we want the values that are only integers. Do you think we can include decimals?
Um, only just no.
No. They are asking about only integers, so no decimals included. And x is something which is only the values which are lying between this. Right. Now, x which is lying between a negative 4 to 1 means x can be a negative 4, x can be a negative 3. Can you tell me what are the other possible values of x?
X can be -2, -1,
Name.
-5,
Okay.
0,
All right.
+1. I mean,
Hmm?
wait, less. 2.
Okay, now let's look at one thing over here. We can take a, so many infinite numbers are there. We can take any number, but they are giving us a condition that x should be lying between a
Less.
and a 1. That is negative 4 and 1 is included because equality is here. And the rest of the numbers should be lying in between. So what do you think? Are all of these numbers satisfying this inequality?
Um, rate less than -4. No.
Which ones are not satisfying the inequality?
0. I mean, 2.
Okay. Why not 2?
Because it's not less than 1.
Yes, not less than or equal to 1. Is there any other number?
Um, no.
All right, so x equals to 1 satisfies this.
Yeah.
X equals to 0.
Yeah.
X equals to minus 1.
Yes.
X equal to minus 2.
Yes.
X equals to minus 3.
Yes.
And x equals to minus 4.
Yes.
X equals to minus 5 is satisfying.
Yes.
Can you tell me how is this satisfying?
Because it's less than 4, negative 4.
Yeah, it's less than negative 4. That point is correct. But over here, what is the value that is required for x? How x should be? When we
X
are,
should,
yeah.
wait, what?
What is it saying over here? If we have to say it, verbalize it, what will we say? What is it? What does it?
X is greater than or equals to negative 4.
That is correct. So is x here greater than equal to negative 4?
No.
Will it satisfy that?
No.
No. So this is excluded. Now over here, all these values we found and they are coming in this category where they are going to satisfy the x, correct?
Yes.
Okay, we found some integer values that they were saying. Now they are saying that all the x values should be such that they should be less than or equal to negative 2.25. So now we see in accordance with this particular thing that x equals to negative 4, negative 3, negative 2, negative 1, 0 and 1. Which out of them is satisfying this? Do you think x equals to minus 4 is less than negative 2.25?
No.
So negative 4, let me change the color. So negative 4 is not less than 2 point, negative 2.25, right?
Yeah, it's not less.
Let's plot it on number line and check. So there is a 0, negative 1, negative 2, negative 3, negative 4. Negative 4 is here. So here is the negative 4. Here is negative 2.25. Let's say it's somewhere here. Now, what do you think? Negative 4 is less than negative 2.25.
What?
Is negative
Negative.
less than 2.25?
No, it's great. No. It's less than.
It's less than, right? So it is satisfying. Okay, great. We will check the next number, which is a negative 3. If it is negative 3, do you think it is less than negative 2.25?
Yes.
Yes, okay. This is satisfying it. Now, we check for a negative 2. Do you think negative 2 over here is less than negative 2.25?
No, but it also says equals, and you said it's all integers, so the 2.5 is there. So yes, it counts.
So over here, is this an integer?
Which one?
The
No.
negative, no, it's not an integer. See, if I just zoom in over here, this is negative 2.25 and the number that we have chosen to compare with is 2. And let's say here is 2. Do you think this 2, negative 2, is less than or equal to negative 2.25?
It's greater.
It's greater, right? So even by 2.25, it's greater. So that means this cannot come in our answer, right?
No.
What about a negative 1?
No.
No. 0?
Nope.
And what about 1?
Nope.
No. So we found that the only integer solutions that could be there for the given particular equation is a -3 and a -4. Any question in any part? Do you want me to repeat once what we did?
Yes, please.
So they are saying that we have to find out the integer values of x for this interval and for satisfying this inequality. So we ignored the top part first. We wanted to solve the inequality. So our first priority over here is solving the inequality, which we have solved by using our previous methods. So after solving it, up till here it is clear, we just solved the previous method for solving the inequality. Solve this inequality and got the answer like we used to. Okay, so our first step is clear. The second thing that they are saying that the answer should be all integers. That means it cannot be decimals. Now, if they should be integer, they should be lying between this. So -4 to 1 should be all integers. So we took the values which is a -4 to 1 only. Any question till here?
No, ma'am.
All right. Now last step, they were saying we just calculated that this x should be less than or equal to -2.25. That means out of these values, we have to choose the values which are less than or equal to -2.25. So we made a number line. We just checked out what are the points which are lying on the left side of -2.25. And we found this and this were lying on the left side. These were on the right side, that means greater points. We didn't want the greater point, we just wanted the less than points. So we found the -4, we found the -3, and those were our answers. Any question and any point here?
Um, can I just like say what we did so far? We
Yeah.
did first, we just solved the inequality and we got -2.25. And
Yes.
then we looked through the numbers that qualified through -4. I mean, x is greater than or equals to -4. X is less than or equals to -1. We were looking for what would satisfy the following inequality. So what would count? And we figured that x equals 1, x equals 0, x equals -1, x equals -2, x -3, x equals -4 are all satisfying -4 like up there. And then we see if those six numbers, if they're also following x is less than or equals to -2.25.
Very good.
And then the ones that did will be their answer. In this case, x equals -3 and -4.
Yes, so there are two solutions in this case. Number one is x equals to a -3, number two is x equals to a -4. And that's what we wanted to find out. Any question at any point?
No.
All right, please take a note of this. Let's go. State all the integer values of x in the interval 1 to 6 that satisfy the inequality given. So the first step, what is the first step?
The first step is to solve the inequality.
Solve the inequality. What are we going to do to solve that inequality?
We would do +8 because it's the opposite of -8.
Yes. What will we get?
5x is less than or equals to 13.
Very good. Now,
Now it's 5 divided by 13.
5 divided by 13 or 13 divided by 5?
I mean, 5 divided by 5, 5x divided by 5, then 13 divided by 5.
Okay. What does it give us?
It will give us x is less than or equals to, let's let me write 2.6.
Very good. So after that, we'll be placing a decimal point, and we got 2.6. All right. Now they are saying the solution is all the numbers which are less than or equal to 2.6. But the values should be lying between 1 to 6. So we want the numbers which are 0, and they must be, okay, let me put the 0 over here somewhere because we have only positive numbers. 1, 2, 3, 4, 5, and 6. So they are saying the interval is 1 to 6 only. 1 and 6 are included. So from here, yeah. So from here till here, 1 to 6 they are saying.
Why is
Okay.
it one? Oh, yeah, never mind.
Yeah. So x is lying between 1 to 6. It's given in the question. So all the numbers which are lying between 1 to 6 are going to come under having a solution. So these are all the values. Integer values, they are saying in the question integer values. So we are going to take only integers. Okay. So now we have taken the integer values of x in this particular interval, but they are over here saying that x is actually less than or equal to 2.6. Now, in this particular interval, what are the values which are less than or equal to 2.6? Oh, 2.6 is going to be somewhere if, let's say, here, let's say is 2.6 somewhere, then they are saying x values should be less than or equal to 2.6. So what are the integer values which are less than or equal to 2.6?
Since it's less than, we would look at the left side. So 1 and 2.
Yes, very good. So the solution is x equals to 1, 2, or we can say separately x equals to 1 and x equals to 2 are the integer values which are going to satisfy our given inequality. Any question in any part?
Um, this was just a statement. Like compared to last question, this one it was a lot quicker because we just used the number line and kept 1 and 6.
Yeah. That one was explained thoroughly because that was our very first question. So over here, when we understood that one, we can just make it a quick short thing.
Oh,
Yeah. Even you won't be needing the number line after some time when we have enough of practice.
yeah.
Please take a note of this, then we'll go for the next question.
Okay.
Let's go. State all the integer values of x in this particular interval and satisfying the following inequality. So what is the first thing we'll be doing? Now you will have to tell me what we have to do.
Okay. First, we'll solve the inequality, which will be minus 6. So negative 4x greater than or equals to 7. Negative 4x divided by itself, divided by negative 4.
Okay.
Same will go for 7.
Is this correct?
No. Yes.
Check once more.
No. The sign will be changed.
Very good. So the inequality will be flipped. What do we get?
The inequality will flip, so then we would get x is less than or equals to Mm, let me write it down. Oh, I can write it. 1 times 4 is 3. Add a 0, 30 should be 7, 8 to 25.
Very good. So we got this is it positive? Is it negative?
It's negative.
Negative 1.75. So on the number line, now they are talking about negative 3 to 2. So here is our negative 3 and here is our 2. And the number that we have found is a negative 1.75. So let's say this is a negative 2, this is a negative 1 here, this is 0 here, this is 1 here, and they have set negative 1.75. So what do we do the next thing?
We would do, since it's less than, we would do, wait, no, anything in between negative 3 and 2. So now we have to look for something in between those that are less than negative 1.75.
Yeah, so we are going to
Which,
plot the negative 1.75 here, and we see that they are saying less than or equal to. So it's less than or equal to and the integer values of x. So what is the thing that is satisfying it?
since it's 3, negative 3 and negative 2.
Yes. So x is a negative 3 and x is a negative 2. These are the two values that are the solutions of this inequality. Any question in any part?
Um, no, not, no.
Okay. Please note this down. Okay, let's. We want to determine the smallest integer value of x in the solution of this inequality. What is the first thing we'll be doing?
The first thing we'll be doing is solving the equation.
Yeah. To solve this, what do we do?
To solve it, we will do plus 12 because it's plus 10.
That's right.
So negative 5x less than or equals to 24.
Now,
Negative 5 divided by negative 5x divided by negative 5. Same to the other side. 24 divided by negative 5 is,
is this correct?
yes, no, the sign will be switched.
Very good. What do we get?
We get 5 divided 4 times 5, 20, 8, 48, 4.8.
Right. So what do we write here?
We would write x is greater than or equals to 4.8, negative 4.8.
So over here, if we draw it on the number line, as there is no interval given, but we just know that there is somewhere negative 4.8. Let's say this is the negative 4.8. They are saying all the solutions are of x are greater than or equal to negative 4.8. So is it going to be the left? Is it going to be the right?
It would be on the right because it's greater than.
Very good. So all these values are going to be the answer for this. But over here they have given a condition Determine the smallest integer value of x. The value which is an integer and which is the smallest. What do you think? What is the value in this whole shaded yellow part, which is an integer and which is the smallest?
Negative 4.8.
Is it an integer?
No, so it's negative 3. Negative 4.
So here is going to be a negative 5. That means here must be somewhere, oh, not here, very close to this. There will be a negative 5, and then there will be a negative 4, a negative 3. So as you were saying, a negative 4, that means x equals to a negative 4 is the only smallest number which may satisfy this. Any question here?
Um, like but we sometimes get equations where it will say like that it's not an integer.
Hmm. Yeah, they will be coming not in this type. We will be doing all the types, but first we learn how to find out, identify the solutions when it is integer. Then other things in the intervals we'll be finding out, in the notations we'll be finding out. But for now, we will be doing only for integers in this particular topic. Any other question?
Uh, no.
Please take a note of this, then we'll move forward to the next part.
Okay.
So, so determine the largest integer of x in the solution of the following inequality. What do we do here?
-2.
What do we get?
5x less than 15. X is less than 3.
Very good. So we are
What
just
is the
going to,
largest integer? It could be anything that's, wait, since it's less, it would be to the left side. But what would be the limit from, like, how far can we go?
there we can go up till infinity. They're asking what is the largest integer of x? What is the biggest over here in the number line? What do you think?
3.
Yeah. Before this is going to be 2, 1, 0. Then there are negatives which are even smaller. So 3 is the largest integer and x equals to 3 is our answer. That's all. Okay, make a note of this. Any questions here?
What
All right.
happens if it were to say this small?
Yeah, so smallest would be all the numbers which are lying between 3 to negative infinity. All the integers which are lying between negative infinity to 3.
Then how would I like in when I'm in delta math when I'm putting in the answer, what would I keep?
You don't need to. There will be this notation over here we will be doing. So, yeah, you will know when this type of thing come. That's why they are just asking for integer values which are like, they will be like x equals to this, x equal to that. These kind of notations are not yet coming. When they will be coming, I'll tell you. How do we solve them? How do we write? What does it mean?
Okay.
Okay. Any other questions here?
No, ma'am.
Okay. Please take a note of this.
No.
You will have to stop the sharing.
Oh,
There was one more thing. I just put a solid dot here. It is not solid, it's a hollow one. This means x is not included and we have to find out the smallest integer.
so it would be 2.
Yeah, so it's 2.
I
Over here,
forgot that it's not less than or equals to like the other ones. It would be 2.
but for this one it will be correct. You will be knowing later, what does brackets means and what does it mean. So over here, There is one more solution, which is this. So there we will be learning how the solutions are like that. Okay. So this is the solution that we got for this.
Wait,
And
if it were to be the smallest, wouldn't we look to the right instead of the left?
largest, yeah, but before that, we will have to find out what is this thing which is satisfying x less than 3. X less than 3 is all the values which are left, right?
Oh, yes.
Any other questions?
No, ma'am.
Great. Let's go.